start solving this? Everyone. Chadwick. Next, Rutherford. Nuclear atomic model. Next, Moseley's X-ray spectra he has used to identify atomic numbers. Then he given the atomic like periodic table based on atomic numbers. Right now? Yeah. So it means what is that? That's it. That is the one you need to match. Yeah. Next, go to the next question. Yeah. So look at this. All these are EAPCET or NEET questions. So don't worry. Like try to solve. All of them are very easy. You can do that. Yeah. Tell me here first one. Beryllium plus 2 is there. So beryllium atomic number? 4. So 4 means plus 2 means how many removed? 2 removed. So now tell me. 2 so tell me. A? 3. That's it now? Done? You can match whatever it is. Next. Fast. Six, 7, 6. See here, C 13, 6 is there. So here it represents number of, like atomic number represents number of protons. For an atom, number of electrons, protons are equal. So its number of electrons also 6. Electrons and protons are 6 and 6. For an atom I am saying, not for ion. For atom, atomic number is equals to number of protons or also number of electrons. Both of them are equal. Now what about this number? Mass number now. So mass number comes from where? Neutrons plus protons. So mass number is 13. So proton numbers is 6. So number of neutrons are how many now? 7. 13 minus 6. How many? 7. So what is our answer? 8. That's it. Is this clear everyone? Yeah. Very basic questions I have started with. Okay. So next, this one you did yesterday. Just leave it. Yeah. Next. Look at this question. What this question says, one see. See, if you look at the options, they are scary little bit. Okay, don't fear by looking at the option. Try to get what is the concept they have used here. What they are saying, once read the question everyone. See, just ఆడి నుంచి కనిపిస్తుందా లేదా అని కన్ఫర్మ్ చేసుకోవడానికి ఏం లేదు. Now see what I am saying. What the question says, what is the concept? Tell me here, what do we use? See, they are saying ejected electron, velocity of photoelectron. Where we studied this? What is that concept we studied? Photoelectric effect, morning class. So what is that equation we used there? H nu equals to H nu naught plus kinetic energy we have used. Velocity they are saying now, so you can make it as half mv square. Okay, so these are frequency, this is velocity. Okay, now they are asking the relation between lambda naught, lambda, respectively a threshold wavelength and wavelength of incident light, then the velocity of photoelectron. It means what we need to say? Velocity. Where do we have velocity? This v, right now. So it means you send all these things this side. So try to create like that. What happens? It becomes h nu minus h nu naught equals to half mv square. See, nu means what? C by lambda. Similarly, nu naught means what? C by lambda naught. That's it now. So wherever I have this hc by lambda minus hc by lambda naught equals to half mv square. Next. So so now here what is common I can take here? hc. Okay. So you can take hc. Okay. And if I bring this to this side, what happens? Denominator becomes numerator now. So 2 is common here. Next, 1 by lambda minus 1 by lambda naught equals to mv square. But I want in the form of v only. So I can bring this m also this side. What happens if it bring m? So we have v square. So if I bring v also like square also. So now look at this kind of option anywhere. So if you observe, they simplified it further. How can you simplify it further? Tell me. LCM. You do the LCM. What happens? Tell me. 2hc by m lambda naught minus lambda. This is what the final answer you will get. Yes or no? So what is our answer? B. That's it. Okay. So initially it looks very scary, but if you follow the steps, easy only. Okay. So try to do again if you want after the class. So morning you did these 2 questions. Yeah. Then next let us move for these things. Radius, Bohr model questions. You want to know? Read the question once. Raghav, read the question. How can we do this? What is the radius formula we discussed in the morning class? Anyone can say. What is the radius of all? Tell me what is the formula here? Radius of nth orbit equals to 0.529 n square by z angstroms. Okay, that's it now. Yeah. So now what they are asking, ratio of radius of second orbit. Now tell me what is the radius formula? 0.529 n square by z. So now what they are asking? They are asking about second orbit of. How can you do this? R2 of what? Which one? Lithium plus 2. So how can you write 0.529 into what is n value? Second orbit. It means 2 square you can write. Z for lithium 3. That's it. 3 square or 3. Z means just 3. Atomic number is 3. That's it. So they are saying ratio na. So this is R2 of lithium. Ratio means you take one more. What is that? That of third orbit. So R3 of what? Beryllium plus 3. So this is equals to like 0.529. Next, n square for this one. How much they are saying for beryllium? 3 square by 4. See, this value we can remove. Next, what is remaining? 4 by 3 by 9 by 4. So you can simplify this as 4 by 3 into 4 by 9. 16 by. So do we have any option? That's it. Everyone got the answer? Yes. Now the next question you write in your notes. Now see, first of all tell me, everyone, you got this or not? Everyone means everyone. Yeah. So now write a question. I will ask you the answer randomly now. Okay. Radius, the ratio of radius of second orbit of helium, ion, it means He plus 1 to that of fourth orbit of helium plus 2 ion. What we are doing? Second orbit of helium plus 2 ion to the fourth orbit of helium plus 2 ion. Helium plus ion, that's it, helium plus ion. Helium plus, not plus 2, it is plus only. 1/4. Everyone? What is the formula? Array, same ive steps follow అయిపోండి. See what we did, what is the radius formula? 0.529 n square by z. So ఇదే ఫార్ములాలో నేను ఇచ్చిన క్వశ్చన్స్కి n వాల్యూ ఎంత ఇచ్చిన? సెకండ్ ఆర్బిట్ అని అన్నా. సో n వాల్యూ ఎంత అవుతుంది? 2 స్క్వేర్. కింద z అటామిక్ నెంబర్ ఎంత హీలియం అయాన్కి? హీలియంకి 2. 2 స్క్వేర్ బై 2 అయిపోయింది ఒకటి. రేషియో అని చెప్పిన కదా, లైన్. కింద ఇంకోటి ఏమన్నా? R4 of same 0.529 fourth orbit, 4 square by 2. Try to simplify that. Everyone 1/4? Yes, sir. Yes. R2 by R4 of helium ion. Yes, tell me. 0.529 into n square, 2 square 4 by z 2, here 0.529 n square 16 by 2. See 529 2 cancel, 1s are 4s are, so that will be 1/4. Everyone? Yes. Next one. This one, what is the formula we used morning? Electron volt. What is the formula to use? Yes. So first of all, photoelectric effect question now, this one. Work function they given. Work function is nothing but energy only. What is that? Energy. So now this much amount of energy must be supplied to the metal so that electron comes out. Okay, that is what the threshold energy or threshold frequency or work function will say. Okay, so now how much energy we are supplying? For that 400 nanometers, what is the corresponding energy? We need to calculate in electron volt. How can we do that? So energy is equals to 12400 by 12400, not double zero, single zero. Lambda should be nanometers. Is పెట్టేసేయండి nanometers ఇచ్చారుగా. So what is the energy now? It becomes so it will be 3.1 electron volt we will get. What is your answer? 3.1 electron volt. Up to here it is clear. This is the energy you are supplying to the metal surface. If that energy is sufficient, then electron comes out. If that energy is not sufficient, no photoelectric effect observed. See, for lithium, how much energy is there, threshold energy? Now how much we are supplying? Is this sufficient or less or more? అరే మనం ఎక్కువ ఎనర్జీ సప్లై చేస్తున్నామా కావాల్సిన దానికంటే తక్కువనా? అరే ఇంత ఇది సరిపోతుంది నికెల్కి, లిథియంకి. బట్ హౌ మచ్ వీఆర్ సప్లైయింగ్? కావాల్సిన దానికంటే ఎక్కువనే సప్లై చేస్తున్నాం కదా. సో ఫోటో ఎలక్ట్రిక్ ఎఫెక్ట్ అవుతుందా, జరుగుతుందా, జరగదా? జరుగుతుందా, జరగదా? సో ఇట్ విల్ బి అబ్జర్వ్డ్ హియర్. నెక్స్ట్ వన్ టెల్ మీ. 3.7 కావాలి, బట్ హౌ మచ్ వీఆర్ సెండింగ్? Is this sufficient? If it is not sufficient, electron will come out or not? No. So it won't come out here. Here? See, they required దీనికి 4.8 కావాలంట, బట్ మనం మీద సప్లై చేస్తున్నాం. Is that enough? No. So no photoelectric effect in this. Here? In this? In this? So how many of them are happening? 1, 2, 3 not happening. 3. 1, 2, 3 not happening. These are happening. So based on that you answer. Next. What is the energy formula we discussed? Bohr model energy. Yes. E energy is equals to minus 13.6 Z square by N square electron volt per atom. This is the energy formula we discussed. Okay, what is the formula? Minus 13.6 Z square by N square. So ఇప్పుడు for example I am asking you what is the energy of question. First you write this question, later we will go to that. Energy of electron present in second orbit of helium or beryllium plus 3 ion. That question is clear or not? Once read the question once again. Energy of electron that is revolving or present in second orbit of beryllium plus 3 ion. So what to do, tell me? E is equals to minus 13.6 into Z. What is Z? Helium or what is this element? What is the atomic number? 4. 4 Z square now 4 square, and here N square. What is the N value I am saying? So 2 square. Okay, that's it. So minus 13.6 into, so 2 square means 4, here 16. So this will be 4 times. So 13.6 into 4 electron volt per atom, how much? So you just simplify that, you will get 4 6 are 24, 2, 12, 13, 14, 4, 1, 5. Okay. So 54.4 electron volt per atom. Let's simplify చేసేయండి. అర్థమైందా? Yeah. So now follow the same steps. Read the question once fast. Ratio of helium plus 2, lithium plus 2, helium plus 2, helium plus and hydrogen. Have you observed one thing? Till now whatever we discussed, all those systems are having only one electron. Like I told you, hydrogen atom or helium ion, lithium plus 2 ion or beryllium plus 3 ion. Have you observed how many electrons they have? One electron here also. One electron only. Helium atomic number is how much? 2. ఇట్లా రాస్తే atom అంటే ఇలా 2 electrons ఉన్నట్టు. But I am writing helium plus. It means from here to here I removed one electron. So ఇప్పుడు ఇందులో ఎన్ని ఉన్నాయి? Here how many are there? One electron only. Beryllium atomic number ఎంత? 4. 4 becoming, like after removing 3 electrons it's becoming plus 3. Now how many electrons are there? 1. So it means whatever the Bohr model we are discussing, it is applicable only for single electronic systems, not for multi-electron system. Okay, right. Now you can see here, these 3 are given. Ground state means n value in the 1 అని అర్థం. Ratio of energies of ground state of these atoms they are asking. Tell me how can we do this? దీనికి తీసుకోండి ఫస్ట్, పక్కకు దీనికి తీసుకోండి, నెక్స్ట్ దీన్ని ఇట్లా రేషియో తీసుకోండి 3. You will just simplify it by putting the formula. 9:4:1. How simple, see here. What is the energy for lithium I should take? Minus 13.6 into Z square. What about lithium? Z ఎంత? Atomic number ఎంత మా? Z square by n square. That is ground state means 1 square. Next minus 13.6 into helium ఎంత? Atomic number 2 square by 1 square. Next minus 13.6 1 square by up to here. See this value, this value, this value same only, now remove it. Next here 9:4:2. Perfect everyone, got this? Just చూస్తున్నారా ఏమైనా చేస్తున్నారా? Next write a question everyone. Energy of an electron revolving, energy of an electron revolving in third orbit of lithium plus 2 ion, is x, then the energy of electron revolving in second orbit of hydrogen atom is. It means like first దానికి ఎంత అని చెప్పిన ఎనర్జీ x అని చెప్పిన. ఇప్పుడు ఈ క్వశ్చన్ ఇప్పుడు నేను లాస్ట్కి ఏమని చెప్పిన, హైడ్రోజన్ ఆటమ్కి ఎంత అని అడుగుతున్నా. ఇది ఎక్స్ 2x అవుతుందా, x/2 అవుతుందా, అట్లా మీరు ఆన్సర్ చెప్పాలన్నట్టు. x ఇంటూ సంథింగ్ వస్తుందమ్మా, అది మీకు వచ్చిన ఆన్సర్ చెప్పండి. ఫస్ట్ క్వశ్చన్ చదవండి మంచిగా. అరే మళ్ళీ ఇంకొకటి, డోంట్ ట్రై టు లుక్ ఫర్ అదర్స్. ఫస్ట్ మీ బ్రెయిన్ కొంచెం పని చెప్పండి ఎట్లా చేద్దామని. ఫస్ట్ 5 ఎలిమెంట్స్ చెప్పండి. ఫస్ట్ సో ఇప్పుడు చేయండి. అరే ఎప్పుడు కానీ నేర్చుకో. Everyone got? Yeah. So listen here. What is the energy formula? Fast. Minus 13.6 Z square by N square electron volt per atom. Next one. What is the question I told you? Energy of electron revolving in which orbit? Third orbit of what? Lithium. Second, third orbit I told you. Okay. Third orbit of lithium plus 2 equals to X. Next, energy of electron revolving in the second orbit of hydrogen atom is how much I am asking. Okay. So now, if you do this, X and cheppina kada, so energy ela chesta minus 13.6 into Z square. Z is how much for this? 3 square by ఇది n value enta 3 square, అది కూడా ఇక్కడ 3 square, so it is cancelled out. So now what is our X value we got? Minus 13.6. What I am asking, you know, energy of second electron revolving the second orbit, so that is also minus 13.6 Z square by N square. What is Z? 1 square by N. సో ఈ వాల్యూ ఎంత చెప్పినా ఇప్పుడు ఎంత వచ్చింది? ఎక్స్. 2 స్క్వేర్ అంటే వచ్చింది ఆన్సర్ ఇలా. వెరీ బేసిక్. యా. సో నౌ దట్ ఈస్ డన్. Again we will come back to energy later. Now try to again do this radius question. Read it once everyone. Got the answer? చేయండి రా. రేడియస్ ఫార్ములా ఏంటి? ఫస్ట్ మనం చేసేటప్పుడు జస్ట్ ఫార్ములా స్టార్టింగ్ నుంచి ఇట్లా ర్యాండమ్గా రాయొద్దు ఎప్పుడు కానీ. ఇట్లా ఆర్ఎన్ ఈక్వల్స్ టు రేడియస్ ఇస్ ఈక్వల్స్ టు ఆర్ ఈక్వల్స్ టు అట్లా రాసి ఇక్కడ మంచిగా ఫ్రెష్గా స్టార్ట్ చేయలేకపోతే ఫస్ట్ ఫార్ములా రాసుకోవాలి. మనకి ప్రాబ్లం రావట్లేదు అనిపించినప్పుడు ఎన్ స్క్వేర్ బై జెడ్. జెడ్ స్క్వేర్ కాదు, జెడ్. ఓకే, ఇది అయిపోయింది. నెక్స్ట్ వాడు ఏమన్నాడు క్వశ్చన్లో? డిఫరెన్స్ అన్నాడు. డిఫరెన్స్ మీన్స్ వాట్? మైనస్. ఓకే, రేషియో మీన్స్ డివిజన్. డిఫరెన్స్ మీన్స్ యూ నో ఆల్ దీస్ థింగ్స్. నౌ టేక్ ద డిఫరెన్స్. ఫస్ట్ యూ డూ ఫర్ ఫోర్త్ ఆర్బిట్, దెన్ నెక్స్ట్ యూ డూ ఫర్ థర్డ్ ఆర్బిట్ ఇంటూ ఎన్ స్క్వేర్ బై జెడ్. ఇది ఒకటి అయిపోయింది. R4. ఇప్పుడు రేడియస్ డిఫరెన్స్ అన్నప్పుడు ఏం చేయాలి? R4 మైనస్ R3 అని చేస్తే అయిపోతుంది ఇక. అట్లనే తీసుకో. ఇప్పుడు R4 రాసినావు, R3 అంటే ఎట్లా రాస్తావు? అది మర్చిపో, దీని గురించి పట్టించుకోకు. ఇక్కడ R3 అంటే ఎట్లా రాస్తావు? ఇప్పుడు R4 మైనస్ R3 రాసి 16 రాసేసి బై 1 మైనస్. ఇప్పుడు ఒకటి చూడు, ఈడ 0.529 ఉంది, ఈడ కూడా అదే ఉంది. క్యాన్సిల్ చేయొద్దు, కామన్ తీయాలన్నట్టు ఇక్కడ. అంతే. ఇప్పుడు మల్టిప్లై చేసి నీకు ఏదో ఒకటి వస్తుంది. Got the answer everyone? A. Once we'll try here. So difference of what? R4 minus R3 of what? Helium. Helium plus. Okay. So what I should take here? 0.529. Radius means what is the formula? 0.529 into n square by z. Look at this. R4 anaru. He is saying R4. Okay. So this can be now for fourth one. And one more is what? 0.529. See. R4 ki itla తీసుకున్నా. Next minus again 0.529 n square by z for R3 కూడా రాయాలి కదా. ఇప్పుడు 0.529 సేమే కదా రెండిటికి, సో I can take it as common. Okay, so 0.529 r n square by z for fourth one, and next here n square by z for third one. Okay, see which atom they are saying both of them are same atom now. Atomic number same hai kada, so can I take z also common? Z also outside? Yeah. So now what happens here? Z also common. What is the n value they are saying? So n square, 4 square, 16, 3 square, 9. Z is how much? Helium or hydrogen? Helium. How much Z? Yeah. So take here 2. So 0.529 by 2 into 7. So this is how much? 0.2 za, 6 za, 8 za, 5 za. So if you multiply, you will get some number here. How much? 1.85. What is the answer? Units. What is the units we got? Angstroms. But they are asking in meters. What I told you, 1 angstrom? Minus 10 meters. Today we discussed it now. So it will be 1.85 into 10 power minus 10 meters. So where do we have? C. This is your answer. First bench. Okay, next. Morning I told you this thing. Do you remember? Yes, sir. Now tell me, electron falling from 6th energy level to 2nd energy level. Balmer series. 3rd energy level? Paschen series. Now electron falling from 5th energy level to 2nd energy level, that line appears in which region of spectral series? Visible. Okay, this is also clear. Okay, so what are the H alpha line of Balmer series? Alpha means first A, like alpha beta, these are nothing but A B C D, like that only na. Alpha means what is that? First line. So from where to where first line in Balmer series? 3 to 2. 3 to 2. If I ask Lyman? H beta line. Beta line of Lyman series. Beta, second line. Yeah, like that. Now tell me number of spectral lines possible when an electron falling from 6th energy level to ground state.
15.
How can you do that? 6th to, what I am saying, 6th to, electron is falling from 6th energy level to 1st. Like this, how many lines are possible? I am asking. What is the formula I given you? N2 minus N1 into N2 minus N1 plus 1 by 2. So what is N2? Bigger number. 6 minus 1 into 6 minus 1 plus 1 by 2. So it is 5, minus 1 plus 1 cancel, 6 by 2. How much? 15 lines. Is this clear? If you want to cross check, draw like this all the possible lines and you count. You will get the 15 lines. Okay? And the next one, Now tell me, if electron is falling from 6th energy level to, what I am saying, 6th energy level to 2nd energy level, number of spectral lines possible. Ten now, everyone? How to do? 6 minus 2, 4 into 6 minus 2, 4 plus 1, 5 by 2. 10 lines. You got, everyone got this? ఇప్పుడు ఇంకొక క్వశ్చన్. అమ్మ ఫాలో అవుతున్నారా? See, why this session I conducted now? ఇప్పుడు ఏదో నేను సిలబస్ కంప్లీట్ చేయాలనో అది కాదు విషయం. ఐఎమ్ నాట్ డిస్కసింగ్ న్యూ టాపిక్స్, ఐఎమ్ డిస్కసింగ్ సేమ్ టాపిక్స్. దిస్ ఈజ్ జస్ట్ టు మేక్ యూ లర్న్ ఎఫెక్టివ్లీ. ఇప్పుడు కూడా అర్థం కాక సైలెంట్గా అట్లా కూర్చున్నారు అనుకోండి, ఇంకేం చేయలేం. ఓకే, అర్థం కాకపోతే మళ్ళీ అడగండి, ఇప్పుడే చెప్తున్నా. నెక్స్ట్ 6 to 1, how many possible spectral lines we have seen? 15 lines. Out of these 15 lines, how many are appears in Lyman series or another other way? Okay, fine. 15 lines వస్తున్నాయి కదా. So out of these 15 lines, how many lines belongs to Lyman series, how many belongs to Balmer, how many belongs to Paschen? Like this I am asking. Question అర్థమైందా? What I am asking, out of these 15 lines that are falling, how many appears in Lyman? It means 6 to 1 appears. 6 to 1 is a Lyman series line. 5 to 1 also Lyman series line. 4 to 1 also. Like that, how many appears in Lyman series? 6. Are you just try it once. ఇక్కడ నెంబర్ 6 అంటే ఇక్కడ ఉంది కదా. Try to get this. 6 to 1 is Lyman series line. 6 to 1 is Lyman series line. Next, 5 to 1 also Lyman series line. 4 to 1, how many you got like that? 5 lines are possible. Out of this 15, how many are Lyman series? 5. Okay. ఇప్పుడు మీరు ఒక ఫార్ములా తయారు చేయాలి ఇప్పుడు చూసి. నెక్స్ట్, how much you got? Answer. So when I ask from 6 to 1, you told 5 for Lyman. Same thing I am asking for Balmer. 4. How you told this 4? Next, next Paschen. 3. Now tell me the formula. You have got something into your N2 minus N1. It means if I say Lyman series, you did it as 6 minus 1. 5 lines you told. Second thing, 6 minus 2. You told it as 4. Paschen means 6 minus 3. You got 3. Like that you calculated. So total sum if you do, you will get the 15. Is this clear, everyone? Yes. Okay. Next question is, so tell your friends whoever absent now, please tell them to watch this. Okay, I will post it in the app or in the YouTube so they can watch it. Okay, it is recording already. Recording. Okay, next. Okay. See, morning we have seen something like this. This is ground level, n equals to 1. This is n equals to 2. Second energy level I can say, or first excited state I should say. What is that? First excited state. Next is this one. State are n equals to 3. Third energy level, like that we have made. But what I told you, as we go upside, energy increases. As n value increases, energy also increases. This story we discussed. Now, but energy gap, what I told you? Decreases. So maximum energy gap present in 192 between these two. Okay. Now they will ask you one question like this. For Lyman series, for Lyman series, come back to this. Energy frequency relation, what is that? E is equals to h nu. Energy wavelength relation, hc by lambda. So more energy, how they are? More energy, lower lambda. Okay. So now what happens as n values increases? Energy also increases. So now for Lyman series, tell me the highest energy difference possible for highest energy difference will be seen in for Lyman series, the highest energy difference possible in which case? Tell me, easy, whatever you are thinking, it is correct only. So energy difference means like E2 minus E1, E final minus E initial, like that only, no? So energy difference means this gap should be maximum. So if it is Lyman series means N1 must be 1 only. So what is the N2 for maximum energy difference? Infinity. So N2 should be infinity, N1 should be 1. This is a story for Lyman series. Similarly, for Balmer series, N2 is infinity, N1 is 2. Perfect. Now, for the same Lyman series, lowest energy gap, lowest energy difference, N2 should be Lyman series I am asking. N1 should be definitely 1, N2 should be 2. See, only here to here. This is a small possible, maximum possible means highest one. Okay, this is about energy. Now, same question I can ask in terms of wavelength. What is the highest wavelength possible for Lyman series transitions? Which one? Highest energy possible? N1 should be 1, that is fixed for Lyman. N2 should be highest energy I am saying. Highest wavelength I am saying. Wavelength. Are amma ikkada chudandi. Energy and wavelength, how they related? Highest energy unta wavelength lowest untadi. So this is, I can say, highest energy or lowest wavelength. Is this clear, everyone? Here I am asking lowest energy difference or highest wavelength difference. So for Lyman series, highest wavelength difference will be seen from where to where transition. N1 must be 1 only, N2 will be 2, that's it. Is this clear? Okay. So ఇప్పుడు మీకు అర్థమైందా లేదా అనేది క్వశ్చన్ చేస్తే నాకు తెలుస్తుంది. లాస్ట్కి I given you one equation called Rydberg's equation. Tell me that equation fast. From the basic, I mean, what is that? Equals to what? Nu bar means what? Wave number equals to 1 by lambda equals to RH Z square 1 by N1 square. ఇంకోటి క్లాస్లో నుంచి until the teacher says here to go out, don't go. Okay, ఇక్కడ నుంచి ఎవరైనా పంపించే వరకు మీరు వెళ్ళకండి. Okay, this is the formula to be used. So what is the RH? I'm saying not for now, it is for every time. Okay, so this is a RH value. How much it is? 1.1 into 10 power 5 centimeter inverse. Okay, so this equation is called Rydberg's equation. What is it? Rydberg's equation. What is the use of Rydberg's equation? See, N1, N2 I am saying, electron transition we discussed. It means during a transition, what is the wavelength associated? Or what is the energy associated? See, if I calculate wavelength, we can also calculate energy. How we can calculate? Is equals to h nu or hc by lambda is here, na? From that you can calculate. Is this clear, everyone? Yeah. So now read the question once. Statement 1 says the Balmer spectral line for hydrogen atom with lowest energy is located at 5/6 RH centimeter inverse. First, then just try to verify this whether this statement is correct or not. Balmer series means what are the numbers you should take? Balmer series, where it is? N1 should be 2 and N2 can be anything greater than that. Okay. Now see what they are saying. Lowest energy. What is the lowest energy for Balmer series? 3 to 2. Everyone got this what we are discussing? అరే ఎక్కువ ఇట్లా డిఫరెన్స్ ఎక్కువ ఉందనుకో ఎక్కువ ఎనర్జీ అన్నట్టు. వాడు ఏమడిగిండు? లోయెస్ట్. సో ఇట్ షుడ్ బి మినిమమ్. సో విచ్ వన్? 3 to 2. Do it now. Everyone verify it whether it is correct or not. N1 ఎంతరా? చిన్న నెంబర్ అందులో. N1 always less than N2 in the equation. N1 is how much? 2 square. అరే చిన్న నెంబర్ ఏదిరా అందులో? ఓకే పర్ఫెక్ట్. ఇట్లా బ్రాకెట్ పెట్టు, సింప్లిఫై చేయదాన్ని. ఎంత వస్తుంది కరెక్ట్ అంటే? ఆర్హెచ్ని అట్లనే పెట్టండి. పక్కన ఎంత వస్తుంది సింప్లిఫై చేస్తే, ఎల్సిఎం చేస్తే? దట్స్ ఇట్. So 1 by lambda equals to RH, this is equals to nu bar equals to RH into z square is 1, N1 is 2 square 4, 3 square 9, 9 minus 4 is 5, 9 4s are తెలుసు కదా LCM fraction simplification into RH. Okay, this is nu bar. See వేవ్ లెంత్ ఆర్ న్యూ బార్. సి వేవ్ లెంత్ అంటే లెంత్కి యూనిట్స్ ఏంటమ్మా? సెంటీమీటర్స్, మీటర్స్, యాంగ్స్ట్రామ్స్ అట్లా రావాలి. ఇక్కడ 1 by lambda అన్నప్పుడు సెంటీమీటర్ ఇన్వర్స్ అంటే ల్యాండా డినామినేటర్లో ఉంది కదా, అందుకే సెంటీమీటర్ ఇన్వర్స్. సో వీ కెన్ సే ఎనర్జీ ఇన్ టర్మ్స్ ఆఫ్ సెంటీమీటర్ ఇన్వర్స్ ఆల్సో. ఓకే, సో వీ గాట్ దిస్. ఈజ్ దిస్ కరెక్ట్? ట్రై టు వెరిఫై సెకండ్ స్టేట్మెంట్. అక్కడ స్పేస్ ఉంది కదమ్మా, అక్కడ ఉంది, ఇక్కడ ఉంది, ఇక్కడనే బాగుందా? వెళ్ళొచ్చు అక్కడికి. గట్ ద ఆన్సర్. మీరు black body radiation, did we discuss a very little bit? I have given introduction, like a graph I have shown you. What happens? Intensity with the temperature increases, wavelength goes towards the minimum side right now. So they are also saying same thing. So when temperature increases, the maxima of curve shift towards, based on that you can solve this. So both statements are correct. ఇది చేయండి. ఏమైంది చాలా? Anyone? See, the energies E1, E2 of two radiations are given. The relation between their wavelengths. E is equals to what? Hc by lambda. So E1 equals to Hc by lambda 1 by E2 equals to Hc by lambda 2. So cancel చేయండి, ఇంకా మిగిలింది ఏముంటే అదే మీ ఆన్సర్. See, everyone see? You got it how we are doing? వచ్చిందా? ఏదో ఒకటి వదిలే. That's it. Next, should I try it? E2 is equals to Hc by lambda 1 by Hc by lambda 2. Okay, so Hc I can remove. So this is 1 by lambda 1. This one goes to numerator, becomes lambda 2. Like this now. So E1 is how much? 25. E2? So lambda 2 by lambda 1 equals to 1 by 2. Then lambda 1 equals to 2 lambda 2. So we have C. That's it. Everyone got this? Sare. This one last question and very important question. చెప్పమ్మా. How do you do this? What will be the longest wavelength in the Balmer series of spectrum? Balmer series longest wavelength. How to say this? Longest wavelength. Wavelength longest means energy minimum. Energy minimum. N2 will be 2. N1 will be 2. N2 will be 3. 3 to 2. Okay, you got N1, N2 values. So substitute. What is the formula given? పూర్తి ఫార్ములా చెప్పండి. 1 by lambda equals to RH Z square. Use that fast. Do it once. Z, if they are not mentioned, take a hydrogen atom. See, I spent almost 1 hour for continuous question discussion. So after completing this session, after going to your hostel or wherever it is, you also should spend at least 1 hour or more than that for chemistry today. Will you do? Should I check yesterday tomorrow? D, how many of you got D? చేయండి అమ్మా. D. So 1 by lambda equals to RH. RH value into 1 by N1 square. N2 square. 5 by 36. Next, this one 1.1. See, 1 centimeter 10 power 7 nanometers. 10 power 7 nanometers. Okay, so now if this is 1 centimeter inverse, this should be also inversed now. So now how much it will be? 1 centimeter inverse means 10 power minus 7 nanometer inverse. Yes or no? Is this clear up to here? Yeah, so try to substitute here. Inverse 1 by lambda. See, 10 power 5, 10 power minus 7, 10 power minus 2. Next, what is the final thing you got here? 1.1 into 10 power minus 2 into 5 by 36. See, 10 power minus 2 means, see, I am just taking lambda. So lambda means 36 by 5 into, this one comes here, 1.1 into 10 power minus 2. If I can write that in the numerator as 10 square is 100. Nanometer inverse become nanometer. Is this clear up to here? Yeah. So now 5 ones are 20s. Okay. The next one, how much this answer will be? 36 into 20? 2, 0, 720 by 1.1 nanometers. Up to here it is clear now? Yeah. So now look at these options. See again, this is simple. Look at these options 5, 5, 5, 6. Okay. See 1.1 means try to write this as 72 into 10 by 1.1, or otherwise 11 you write and you put 10 power minus 1 aside. See 11 7s are 77. No, it is less than that. 11 6 are. So with 6 only one option we have. Not required even to simplify also. So this is my option, no? B. That's it. Yeah. Remaining we will do in the next class. Take this.